What's up, everyone? Welcome back to Geometry with Mr. G. Today we're talking about parallel lines cut by a transversal. I'm going to use red for parallel for today's lesson. I'm going to use green for transversal in today's lesson. Reminder, parallel lines are two lines that never touch. They never intersect, right? And there's parallel lines. And your transversal is a line that cuts across two or more other lines. So this is actually our first fill in the blank. Transversal. It looks something like this. A line that cuts two or more other lines. See how it's cutting the two parallel lines? That's why we call it transversal. So what we're actually looking at in today's lesson is the angles, the type of angles and the angle relationships formed when you have parallel lines cut by a transversal. Going to the first one here. We've got parallel line here in red. I've got my transversal here in green. And we're looking at the two stars, right? The two stars here. And there's a name for these angles. Go ahead and put arcs here. These are congruent. These are called alternate interior angles. Those are called alternate interior, right? Alternate interior angles. And they are congruent. So when you see this angle relationship, you should be thinking part equals part for this type of problem. Looking at the next one, we've got parallel line here. Second parallel lines here, right? So you always have to have two lines for two lines to be parallel, right? So there's those two parallel lines. And then our transversal is here. Okay, and then we look at where the two stars are now. We're talking about those two stars. We have, these are called alternate exterior angles. These are alternate exterior angles. And that means this angle is congruent to this angle, as we can see there. Now, just to kind of talk about what alternate and interior versus exterior mean, we have alternate is talking about how, if we look at the first one here, this angle, the first star here, this one here, and this angle here, at the second one here, this angle here, those angles are on different sides of the transversal, right? If I'm looking at, let's erase that arrow. I'm looking at this one first. This angle is on the right side of the transversal, right side of the transversal, whereas this angle is on the left side of the transversal. Not only is it on the left side, but it's also touching the bottom parallel line, whereas the other angle is touching the top parallel line. So that's where we get alternate from. And the interior comes from the fact that the two angles we're referring to here are inside. If you can see here, they are inside our two. Here's the parallel line 1, here's parallel line 2. The angles we're talking about is inside these two angles, right? It's in the inside of those two parallel lines. Okay, so that's where we get interior. Versus the other set over here, we've got them again. This angle here is on the right side of the transversal, and it is touching the top parallel line, whereas this one is on the left side of the transversal and is touching the bottom parallel line. So that's where we get alternate from. And then we get exterior from the fact that, again, here's parallel line 1, here's parallel line 2, but the angles we're looking at are outside, right? They're outside of the two parallel lines rather than inside. So that's where exterior comes from. Good. These angles are also congruent, which means when you see these type of angles, you should also be thinking part equals part. Moving on. So for our third set here, we've got parallel line number 1, parallel line number 2, and we have our transversal, which cuts those two lines. Good. We're looking at this angle here and this angle here, right? The ones marked with the stars. And these are called corresponding angles. Corresponding angles. And here's how I like to think about corresponding angles. Actually, really simple. What I like to do is I like to think about it this way. Let's pretend I was numbering these angles, right? I call this angle 1, angle 2, angle 3, angle 4, right? 1, 2, 3, 4. And then let's go to the bottom section down here, right, where the other star is at, and let's number these angles the same numbers, right? So this would be 1, 2, 3, 4, right? We numbered it the exact same way. The way I like to think of corresponding angles is the angle that we're discussing here, right? The top set. Let me go ahead and erase that. the top side up here, right, I'm going to refer to this as the top angle, the star is on the 1. So if we look at the bottom set of angles, right, these bottom 4 down here, corresponding to that 1 should be the same angle 1 down at the bottom, right? So then again, so these are 1 and 1, right? And then angle 2 would correspond with angle 2 down here. Angle 4 would correspond with angle 4 in the bottom, and angle 3 would correspond with angle 3 in the bottom as well. And these are also congruent, which means you should be thinking part equals part for these type of problems. All right, and then the last special case, or the last special type of angles we get, let's go ahead. We've got parallel line 1, parallel line 2, cut by our transversal, and we are looking at two angles that are now they're inside, right, inside the parallel lines, because here's parallel line 1, here's parallel line 2, right? So, and the angles we're talking about are inside those two parallel lines. However, they're not on alternate sides of the transversal, so they're not alternate interior. These are actually called same side interior, right? Because they're not alternate, they're on the same side. So we call them same side interior or consecutive interior. Same side interior or consecutive interior angles. That is the name for these types of angles. And you'll actually notice when you look at the picture, right? If we look at this angle, right, the one I'm coloring yellow here, the classification of that angle would be acute, right? You're looking at that, it's obviously less than 90. Now, if you look at this angle up here, the other one, that's obviously greater than 90, so that's obviously going to be obtuse angle. So you shouldn't be thinking congruent. In this case, they're actually supplementary. And supplementary means we should be using part plus part equals 180, right? The whole here would be 180. So those two angles should add up to equal 180 degrees. Now, real quick, I wanted to go over something that we've already learned from a prior lesson. Make sure we remember this. If you look at angles 1 and 2, right, these angles here, 1 and 2, we should remember that that is a linear pair, right? Those are two angles that are adjacent, and they are supplementary because they're sitting on top of a straight angle, right? They add up to 180. We still need to know those angle relationships in this lesson as well, right? We're going to need to know those for probably the rest of the year. And if you remember, we also have, look at angle 1 down here and angle 4 down here, right? Those are congruent angles. These angles are called vertical angles, right? They form opposite V's, and vertical angles are always congruent, right? So, again, for vertical, we should be thinking part equals part, and for linear pair, should be thinking part plus part equals 180. Make sure we don't forget about those. Okay, so now we're on the back of the notes, and we're looking at number 1. We've got some examples here. Number 1 saying, what is the transversal? I want to make sure you understand which line is the transversal in this picture, and we got to be able to identify that, right? So what do I have? I have line M, I have line A, and I have line B. Those are the 3 lines I have. And remember, the transversal is the line that cuts 2 or more other lines. So clearly we can see that line M, right? Line M is our transversal line because it is cutting lines A and B. So what are the parallel lines? Well, if you haven't noticed yet, these are little markings here, these little arrows. That's an ugly arrow. Here we go, arrow here, arrow here. That is the symbol that represents or tells us that those two lines are parallel to each other. So the two parallel lines here would actually be line A and line B, right? Those are our two parallel lines. It says, which three other angles would be 120 degrees, right? Which 3 other angles would be 120 degrees, and how do you know? Okay, so look at this angle here, and basically the question's asking us which 3 other angles would be congruent to that angle, right? What are the other angles in this picture that would equal 120 degrees? Well, you should be thinking angle 4 immediately. That's from a prior lesson, right? Angle 4 because those are vertical angles, and vertical angles are always congruent. You should be thinking angle 5, right? Because if you look at this angle here and this angle here, right? Angle 5, because those are corresponding angles. They're in the same spots. Corresponding angles, right? Over here where the 120 is at, let me just go ahead and erase these arrows. Right over here, the 120 is in the top left. Over here, the 5 is also in the top left. So they're in the same spot, so we call those corresponding. And then we've got another one. That would be angle 8. And angle 8 because they are alternate alternate exterior angles. Real quick as to why. Again, let's go ahead and erase these arrows. So we're referring to this 120-degree angle and angle 8, right? Angle 8 right here. We know that these angles are also congruent, and the reason why is they're alternate exterior. What makes them alternates? Well, this first one here is on the top side of the transversal, right? It's on the top side of the transversal, and it's touching line A, the parallel line A, whereas angle 8 is on the bottom side of the transversal, and it's touching the other parallel line B. So that makes them alternate. They're alternate of each other. And then exterior, because again, if you look at lines, the parallel lines, right? Line A is here, line B is here. The angles we're talking about are outside of the parallel lines, right? They're outside the parallel lines. So therefore, these are alternate exterior angles. Good, moving on. Number 4 says, find the value of x and explain your reasoning. Okay, so go ahead and box in what we have here. We're looking for value of x, and then we're going to explain our reasoning. So what can we use here? Here's what I'm thinking. We know that this is 150-degree angle, 115, sorry, and this angle here are vertical angles, right? Which means that this angle here is also 115 degrees because vertical angles are congruent. So if I'm explaining my reasoning in steps, I'm just going to say, because vertical angles, then, right, because vertical angles, then we know that this angle here, the 115, and this angle here, the x plus 5 degrees, those are a type of relationship we just talked about. Those are actually same side interior angles or consecutive interior angles. Same thing, just different name, 2 different names. And if you remember from the front page, these 2 angles, the 115 and the x plus 5, should add up to equal 180, right? These are supplementary. So what I'm going to finish putting here in writing for my reasoning is because vertical angles, then same side interior. Now let's go ahead and actually solve this for x here. Again, we know that the 115, right? We've got part plus part equals 180. One of our parts over here, I'll use a different color. We'll call this angle right here part 1 and call this one part 2. So we've got 115 plus x plus 5 equals the whole, which is 180. Solving for x, we've got 115 plus 5, which is 120. So we're left with x plus 120 equals 180. Flip the sign when you're crossing the line, right? So minus 120, minus 120. We get x equals 60. And there's our answer, right? Find the value of x. X is 60. Moving on, looking at number 5 now. And I do want to mention before I move on, there are a lot of different ways to do this problem. A lot of different ways, right? One quick way I'll mention before moving on, actually, you could have looked at this angle here, this 115 that I'm pointing at, and said, hey, this whole angle here, that's a linear pair, right? So you could have done 180 minus 115, which is 65, right? Right, and said, okay, that angle is 65. And if that's the case, you could have done this 65-degree angle here, and the x plus 5 degree angle here. Those are alternate interior. You could have done 65 equals x plus 5 and used part equals part there. So yeah, there are so many ways you could have done this problem here. All right, looking at number 5 now. It says find the value of x and explain a reasoning. So similar type problem. So let's do this. Let's go find the value of x and explain our reasoning. How do I want to do this now? The way I'm going to do this one here is, again, I know that this is a linear pair because it's on top of a straight line, line C. And I know that has to add up to 180 degrees, right? This whole would be 180 degrees. So in order to find the other angle, I'm going to do 180 minus 136, which gives us 44. So this angle over here is 44 degrees. And then I know that this angle here, which we're calling in green, and this angle here are congruent because those are alternate exterior angles, right? They're on different sides of the transversal. One is on the left side touching the top parallel line, and one is on the right side touching the bottom parallel line. So they're alternate, and then they're exterior because, again, if you look at this parallel line and this parallel line, the angles we're talking about are sitting outside the parallel lines. And we can use part equals part here because alternate and exterior angles are congruent. So part equals part, I'm going to get 44 equals 7x plus 9. Go ahead and solve for x here. I'm going to do minus 9 on both sides. And you're going to get 35 equals 7x divided by 7 divided by 7. And we end up getting that x equals 5. Good. And let's move on to the last one now. Last problem here. Oh, we didn't explain our reasoning. Good point. So my reasoning here would be because the first thing we did was we used linear pair, right? Because linear pair equals 180. And then alternate exterior angles are congruent. So there's our reasoning for that one. Looking at number 6 now, last one. Let's do a proof now, a two-column proof using parallel lines cut by a transversal. So we have prove that if two lines are cut by a transversal, right? If two lines are cut by a transversal, then the pairs, right? If then, this is our conditional statement here. Then the pairs of alternate interior angles are congruent, right? Prove that. Okay, cool. So good. The first reason for every two-column proof we always know is given. So there's our given. We're trying to prove that angle 1 and angle 2 in this picture. I have to look at the picture, angle 1, angle 2, trying to prove that those are congruent. So that is why that is in our proof statement. Because that's what it asks us to do, right? It says pairs of alternate interior angles are congruent. That's what we're trying to prove. And 1 and 2 in the picture, those are our alternate interior angles. So we're trying to prove those congruent. And we're trying to prove those congruent given that P and Q are parallel, which in the picture we know that because of the arrows, right? So that's our given information, which is our first statement. So we ask ourselves, okay, cool. How did they get from statements 1 to statement 2, right? Statement 2 says angle 1 is congruent to angle 3. How do we know that 1 is congruent to 3? Well, we know that if P is parallel to Q, then by definition of corresponding angles, so I'm just going to put corresponding angles, that angle 1 and angle 3 have to be congruent, right? We already talked about that on the first page. Angle 1 and angle 3 are congruent. So if P and Q are parallel, 1 and 3 are congruent. And then we ask ourselves, okay, so how are they getting from statement 2 to statement 3? Statement 3 says 3 and 2 are congruent. Well, we know 3 and 2 are congruent because look at where 3 and 2 are. Those are vertical angles. They're across from each other, right? They share a vertex right across from each other. So we would say, okay, those are congruent because of the definition of vertical angles. Good? And then we look at the last one and we say, okay, now how are they getting from statement 3 to statement 4? How do we know that angle 1 and angle 2 are congruent? Well, if you look at the previous two statements, right, look at statement 2 and look at statement 3, something we briefly talked about last class, there is something that's mentioned in both of these statements that we can eliminate and combine what's left. And there's a name for that, right? We can look at statement 2, cross out the 3, look at statement 3, cross out the 3, right? Eliminate what's the same, combine what's left. Angle 1 is congruent to angle 2. And the name of this property was the, well, let me use a different color. The name of that property is the transitive property. And that is our two-column proof. Now, I do want to add one more key thing before I let this video end at the very bottom here, and that is that nothing in this video is true unless the two lines are parallel. That's very key. And as your teachers, we will definitely hit up on this more in class. Well, if you have any questions, let us know. Thank you.